All right, so that brings us to the actual lesson for today for 3.4. And 3.4 is about volume. Volume is a measure of how much space a solid will occupy. So we can talk about the volume of various basic shapes. We have a prism, which is kind of our most basic of shapes. And you can see it here as a triangular prism. The volume of a prism is the area of the base times the height. Now, you want to be careful when you're talking about this, that you understand what base means in this context. In this context, the area of the base, that means the surface that is extended through space. So this one is a triangle, and you see that it's a triangular shape all throughout of constant size. So anywhere you cut this prism, it's going to have that same cross section. That's what we call the base in this formula. So here for this triangular prism, it would be the area of the triangle times the length of the prism. So the height then refers to how far through it is, even if it's not standing up on its end. When we talk about the volume of a box, which could either be a rectangular prism or a cube, it's going to be length times width times height. And of course, with a cube, these are all the same. When we look at the volume of a cylinder, the area of that base is going to be pi r squared, right? Because it's got a circular base. So we're going to take the length, the area of that base, and multiply it by the height. So it's just going to be pi r squared h. So let's move on to some examples. And I'll erase this stuff that's here already. So we have a fish tank. It's a rectangular prism, 30 inches long, 24 inches deep, and 18 inches high. Want to know how much water it's going to hold, and the amount of water it's going to hold, the capacity is similar in concept to the volume. It's how much space it takes up too, right? So this is going to be 30 inches times 24 inches. Sorry, let's start with volume equals length times width times height. Right, so volume is going to be equal to the length, 30 inches, times 24. Now this says depth, and we're using width instead. It means the same thing, times 18. And if I pull up my calculator and do those calculations, 30 times 24 times 18 is 12,960. And this is going to be inches, and those inches are going to be cubed. Right, so it's important to use the right units, and for volume, we're always going to have cubic units because the amount of space something takes up is similar to when you've got a cube. Right, that cube takes up space, whereas a square does not. It's just a flat thing, so it doesn't take up three-dimensional space. Volume does. So fish tank in cubic inches, and I didn't draw a diagram, but I guess the hint says I should. If I were to draw a diagram, I'm going to have 30-inch long base, 24-inch or 18 inches high, and sometimes the word depth is used to mean like horizontal depth. In this case, that would be the 24 inches depth there. And your fish tank might look something like this. Probably won't be broken on the back, hopefully, or else your fish are going to escape. And so we get 24 by 18 high by, no, this should be 24. This was 30. Right, 30 by 24 by 18 is 12,960 inches cubed. All right, let's take another look at another example. That one was fairly simple. If we want to figure it out in cubic feet, then we want to redo this. We want to convert length, width, and height to cubic feet before we go forward. So we've got this fish tank. And here's where the diagram comes in handy because it reminds us to change all our measurements. So we've got our 30 inches wide. We've got our 24 inches, what they call deep, and we got 18 inches high. Now we want to convert each of those into feet. So when you divide it by feet, by 12 inches per foot, so there's 12 inches in 1 foot. If you had 12 inches, you know it'd be 1 foot. 12 divided by 12 is 1. So 18 divided by 12 inches per foot, and you're going to get 1.5 feet. Or, I should probably do this the way I taught you in class. We're going to take our conversion factor of 12 inches per foot, right? We know 12 inches equals 1 foot, and so we're going to set that up as a fraction. It's either going to be 1 foot over 12 inches, or it's going to be 12 inches over 1 foot. And as you can see here, we've got inches on top, so we're going to multiply this by 1 foot divided by 12 inches. It has the net effect of going 18 inches divided by 12 inches per foot. And that will give us 1.5 feet for that dimension. 24 inches times 1 foot divided by 12 inches will give us 2 feet. And 30 inches times 1 foot for every 12 inches. We're going to divide 30 by 12, and that'll give us 2.5 feet. And now when we rework the volume formula, volume equals length times width times height. We're going to have volume equals 1.5, or sorry, length is 2.5 feet, times our width, which was 2 feet, times our height, which was 1.5 feet. And we're going to get an answer of 7.5 feet. And again, that's not normal feet, that is cubic feet, because we are talking about volume. So 2.5 times 2 times 1.5 gives us 7.5 cubic feet. Notice the difference here. It's not just converting from, oh, my answers are all on the other page. It's not just converting from what we had on the other page and dividing by 12 to get to our thing. We'd actually have to divide by 12 3 times in order to get down to 7.5 feet cubed from our answer over there. So you'll notice that we've done that 3 times as we've done the 3 dimensions. It's usually going to be easier to convert your linear measurements, so that's the measurement of a single line, into different units first, and that way you don't have to remember to do multiple conversions. Okay, so let's take a look at another question. Let's clear all this, and we'll move on to this one. Okay, so we have a garden bed, which is 4 by 3, and a 6-inch layer of soil will be spread over the garden. Bag of soil contains 2 feet cubed of soil. How many bags are needed to cover the garden? Okay, garden bed is 4 by 3, and we got a 6-inch layer. Normally this keyword cover, normally the word cover here is going to imply surface area, but because we're talking about soil and soil is thick, it's not like something you buy by the square inch, something you buy by volume. So we're going to have to figure out how much volume there is. We need a 6-inch deep layer of soil. And we want to know how much is required, and our measurement is going to be in feet cubed because that's what the bag of soil contains. So we want to convert all these measurements into feet cubed. Let's start again by drawing a diagram and see how this works. So we've got, here, let's make it brown because it's going to be soil. So we've got this plot, which is 4 feet by 3 feet. So this is 4. And this is going to be way easier if I change to a pen mouse. This is 3 feet. This is 4 feet. And then the depth of this is not very much. It's just 6 inches. Right? It's just a thin layer of soil. And we do need to have all our dimensions the same. So 6 inches. 6 inches equals 6 divided by 12, or it's equal to 0.5 feet. So we want to make sure we put in 0.5 feet on this dimension. Okay, so 3 feet by 4 feet by 0.5 feet. So our volume is length times width times height. In this case, it's going to be 4 times 3 times 0.5, which is going to be 6 cubic feet. And a bag of soil contains 2 cubic feet of soil. I need 6 cubic feet of soil. So how many bags am I going to need? Well, I've got 6 cubic feet up here, and I've got this, essentially it's a conversion factor, right? How much one bag is equal to. And I want to know how many bags, not how many cubic feet. So I'm going to take this conversion factor, I'm going to take my 6 cubic feet, I'm going to multiply that by my conversion factor of 1 bag divided by 2 cubic feet. And that's going to give me a result the same as dividing by 2 cubic feet per bag. So 3 bags. All right, hopefully that makes sense to most of you. I'm just going to stop this video now, and then I'm going to start a new one in a second for further examples.